Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and it is an honor and a privilege to serve you today as you step into my virtual math classroom. And I'm going to teach you a little something about modeling with functions. So really pretty much creating some equations out of word problems and equations that must be functions. Full disclosure here before I get things started, I have a bad back issue. I slipped a disc a couple days ago, saw a chiropractor, all's getting a little better, but I'm not great. I'm feeling very foggy even up here as well. So if I'm not my normal self when it comes to being animated, that's because I can't move much back here, and also just because I don't really feel the emotion diving in too much. But let's go and get started. I actually am limited to a half hour of time here. I have 20 problems for you, and the first couple I'll slow down for. Then I have like about 10-ish or so that are kind of going to be the same kind of problem. Probably go through them kind of fast. And then the last 8 or so are kind of the same-ish kind of problem. So might slow down with a couple and then speed on through. 20 problems, less than 30 minutes now. Let's go ahead and get started. Starting with problem number 1, which actually has 4 parts here. Identify the dependent and independent variables in each situation. So parts A, B, C, and D. What is dependent and independent for variables? You might have heard of independent as being essentially your x, and your dependent essentially being your y, and that's not wrong. If you have a y equals kind of equation, that is what we are dealing with. Something where x is the independent and y depends on it. Y equals something in terms of x. I substitute something freely for x, the independent, and y depends on it because depending on what x is, you get something for y. That was a lot of garble there. But that's what it looks like here. The difference is we are going to be referring to functions only. So instead of using y, we'll be using something such as f of x. F of x means that your y variable is a function of x specifically, and a function meaning that for every x there exists only one y value. When I substitute something for x, I will only get out a single y, and that's kind of nice. Later we'll be evaluating functions at certain inputs with certain variables, and this notation really helps for that kind of thing as we work through. Okay, so number 1, let's identify the independent and dependent variables in each situation. Try and think as real world as possible, but at the same time look at how it's read. The real world stuff will come in a little more importantly later. The total cost of running a business is based on its expenses, and is based on is going to be a very important key factor here. The total cost of running a business depends essentially on the expenses. However much we spend for things, that will determine how much our total business costs. So its expenses, this is going to be the independent guy right here. Independent variable is the expenses. However much we expend determines how much the total cost of running the business will be. So the total cost of running the business, of course, is then the dependent variable right here. So that's all they're asking us to do. Identify what is the independent and what is the dependent. And as you decide something for one, the other gets changed as a result. Letter B, the price of a house depends on its area. Now, I've seen this problem a couple times before, and I'm still not sure if they're talking about the area, like square footage of the house, or the location of the house. It really shouldn't matter when it comes to real world talk about it. The bigger the house is, likely the more it costs. Assuming everything else is kind of the same. Also, likewise, some different areas are going to cost differently. I live now in the greater Sacramento area, and I used to live in the Bay Area near San Francisco. And if you're there, you know, it's a huge high premium to buy a house of the same exact square footage and landscape and neighborhood appearance as where I live right now. Like a lot more, like over 3 times more. So I moved out here as a result. But regardless, it looks like the area is going to be the independent variable right here, area, because depending on what the area is, location or size, your cost will be a function of that basically. Your cost depends on the area. So the dependent variable there, of course, is the price of the house. Okay. And of course, it says that depends on its area. So I'm going to go faster for these next two. The time it takes you to run a certain distance depends on the distance, right? How fast can you get here? Well, it depends. How far away are you? Okay, so based on that. Now it's interesting with this one that time is going to be the dependent variable because generally time is the independent variable. And by generally, I pretty much mean always. This is a situation where it doesn't really say it, but that's because our function isn't already established yet right here. So the independent is going to be the distance this time, and then the time is the dependent variable right here. And again, normally time is just going to be your x. Think of like a timeline from left to right, what's happening as something occurs. That way we can talk about the fact that you can't be in two different places at the same time, and that's what determines whether something is a function or not. In this case, they're not really talking about functions. It's just, can you identify variables? And lastly, part D, the number of items in a carton depends on the size of the carton. So I can choose the size of a carton, and because of that, I can then determine how many items I can fit in that carton. That makes sense. And I don't know what a carton is. I'm thinking of like a big crate, like things where you can store like milk in or something like that. Number of items that go inside the carton. All right, so those are the independent and dependent things right there. Those are pretty straightforward as far as how they're read. We can obviously interpret what they are because how they told us it. It's going to get a lot harder as you go through, but understand that time is normally the independent, and then the dependent is a function of whatever it is we're doing there. A lot of them are going to involve money and time. Some of them obviously change up a little bit. Let's go ahead and take a look at the first one here. It's going to be a little different from the others based on what they're asking you to do. We just want to write the function in function notation for the situation. A function notation means f of x equals. Eventually, my answer is going to say f of x equals and something in terms of x. I have a function in terms of x, a function of x. So I know an x is going to exist here. So I'll talk about this one a little bit longer than the others, and the others will probably come through a lot faster. In order to do this here, I have to determine what my dependent variable is and what my independent variable is in this situation. Charles will babysit for up to 4 hours and charges $7 per hour. Let's write a function for that. What we have to do is identify what are the two things that we don't specifically know just yet that can vary, and based on it, which one depends on the other. And the things that can vary here look like time and dollar amounts. And you might say, well, wait a second, he's going to babysit 4 hours and here's how much he charges. Oh, be careful. He can babysit up to 4 hours. That means he could babysit less time, all the way up to 4 hours and stop. So there is variance there, possibly. The other part is, yeah, $7 per hour may be a fixed rate, but I'm talking about the total amount of dollars that he's going to earn here. So there are two variables in play. The independent variable, in this case, is going to be the amount of time that he babysits. That's time, that's in hours. And the dependent variable is the amount of money that he makes in total based on the amount of hours that he babysits. That's why one's independent and one's dependent. The money earned in dollars. So when I write an equation, what I'm saying here is that the money earned is a function of the time that he babysits. Now, it's not one-to-one. In other words, if x is 1, if time is 1 hour, this isn't necessarily just, boom, $1 or something like that. We want to use, because right now what we have is a unit in dollars, and right now we have a unit in hours right here. Dollars does not equal hours. We need to come up with something where it says dollars equals dollars. And the only way it's going to work, and that's why I'm writing this one time, the only way it's going to work here is if I multiply hours by something that eventually cancels out hours and leaves me with dollars. And what better way to do it than to look at something here that says dollars per hour. Per in reference to like a fraction, like miles per hour. Miles over a certain number of hours. So what I'm going to do is take something that is dollars per hour, and when I divide hours by hours here, just like anything else like variables, they cancel out. So as long as I do that multiplication there, I take a fixed rate of dollars per hour and I multiply by number of hours, that will give me dollars. If that doesn't make sense to you, let's put real terms in it. $10 per hour. Say you make $10 per hour and you work for 8 hours. How much money did you accrue? $10 per hour times 8 hours gives you 80 total dollars. That's what we ended up doing here. So the function here, the function of x, the amount of money that he's going to earn, what you're going to do is take you $7 per hour that he earns times the x hours that he earns. X, of course, only going up to 4 hours total. They didn't ask us for domain things in this problem. I'll save it for a different problem where they do. I only have 20 minutes left, but this is going to be the function for this particular situation here for Charles's equation. Now, we didn't use the 4 hours in this equation. Understand that hours is a unit that can't be applied as a separate term. Everything here has to end in dollars. Dollars equals dollars. 7x is a dollar amount. 7 times 2, $14. 7 times 10, which he can't work 10 hours, $70. But he can only work up to 4 hours, and we'll talk about domain restrictions there. So identifying the independent and dependent variable will be an important thing each time. I won't write it out each time. You're going to learn it a little more as I go. But let's go ahead and continue here. Let's go to number 3. And now the next 10 problems or so are going to be the same thing right here. For each situation, we will identify the independent and dependent variables, then write a function in function notation, and then use the function to solve the problem. Now, I want you to know there's a split between one sentence and the other. This is where we define the where we identify the independent and dependent variables. This is where we also write the function in function notation. This is where we use the function to solve the problem. Every single one of these problems, I am totally in understanding that you can solve this on your own, but in doing so, that means you can also write it in function notation, and it's being asked that you do that. Elmira earns $50 an hour. How much does she earn in 6 hours? Point blank, I'm sure you know the answer, which means you can probably write the function. This is just like the last one. So Elmira earns $50 an hour. So $50 is a constant rate. Once again, this is not a variable, but there are two variables in time and in dollars earned. Time, the time is in hours, and the dependent variable, of course, is dollars earned for the same reason as the last one. Depending on the time, that tells you how much money you'll end up making. 3 hours, boom. So same thing as last time there. And let's go ahead and say that I'm going to use x and f of x again. The function of x. This is a lot like the last one. You take $50 an hour, you multiply it by the number of hours that you work, and then boom, that gives you how much money you've earned over time. Dollars, the money earned is a function of time in that this rate applies. So there's the function. That's in function notation we're taking care of. Then use the function to solve the problem, how much does she earn in 6 hours? Recall that we're looking for when x equals 6, basically what does y equal? Now you don't see a y here, but remember f of x and y are the same thing. But what helps about using f of x here, besides knowing that there's only one answer for this 6 here, is that I can substitute it like this. It looks like this. F of 6. Notice how 6 takes place of x in the notation here. F of 6. This doesn't say f times 6, even though on this side, this says 50 times 6. Not scientific notation. Function notation looks like multiplication if you have something with parentheses here. This is how some function forms just apply themselves. The function of the money earned for 6 hours worked equals $50 per hour times 6 hours worked. So f of 6, the amount of money I'll make for 6 hours worked is $300. 300 earned. And that's what it looks like. F of 6 equals 300. That means that at 6 hours, you make $300. That's it. Because of that, I'm going to work a lot faster once again, now that you understand how to identify it. Number 4, Stan, a local delivery driver, is paid $3.50 per mile driven. Again, fixed rate. This is a rate here. Plus a daily amount of $75. Okay, interesting. Now we have a starting value here. There's something where he already has money applied to this. Okay, let's go and use that. On Monday, he is assigned a route that is 30 miles long. How much is he being paid for that day? So obviously there's a break here again. They're going to give us a certain distance, and based on that distance, we're going to be told how much he's paid. So the same thing as before, where the independent variable now is depending on the distance. So independent is distance. That's in miles. Depending on the distance, we'll know how much he is paid. So dependent, once again, just money. It looks like it's in dollars again. And I state dollars, even though this shows dollars and cents. $3.5 is being applied right there. 50 cents is $0.5. Plus there's a $75 thing here. So we have another f of x equation here. The function of x, basically, the amount of money earned total is $3.50 per mile driven times the number of miles driven. That gives us how much money he earns for that day. Excuse me, for the driving portion. But he also gets paid a daily amount of $75, meaning whether he drives 20 miles, 1,000 miles, I guess 0 miles, he still gets to see an extra $75 in addition to that. So this is all for a single day, and on Monday, he's assigned a route that's 30 miles long. He'll drive 30 miles and get paid for that. Plus, he'll get paid a base value of $75 here. Keep in mind, everything that we have here is dollars. This is clearly dollars. This is the dependent variable f of x. $3.5 per mile times the number of miles. Miles cancel, you're left with dollars, plus dollars here. You have to make sure that your variables, excuse me, not your variables, your units agree with each other. Like variables, like terms can combine here. Dollars plus dollars equals dollars. That all works out. So here's our function. Here's our function. We will evaluate this function for 30 miles driven. So I'm going to go ahead and do f of 30. I'm going to substitute 30 for x and determine what this answer will be. He earns $75 plus $350 per mile for $3.50 per mile for 30 miles. That gives you, oh gosh, $105, I think. $105 plus $75. So f of 30, the amount of money he'll make for 30 miles driven for a single day is $180. I'll go and put this here. I'm running out of time. I don't know if I'll get through all this. I'm only on number 4. Moving on. A lot of the problems will be the same. Bruce owns a small grocery store and charges $4.75 per pound of produce. Again, per pound. Based on the pounds, we can figure out how much money. If a customer orders 5 pounds of produce, how much does Bruce charge the customer? So again, independent variable in this case is the number of pounds. This is weight in pounds. Based on the pounds, I can determine how much he's going to charge. Okay. Dependent variable is total cost. Excuse me. How much does he charge? Yeah, total cost. This is again in dollars. Now, you don't have to use f, by the way, for function of x. In fact, I'm going to use some different variables here. Let's use d for dollars and p, c for cost, just to show you that you don't have to use f and x. As long as you identified what they are, d is the independent variable, c is the dependent variable, represents the function, I can write c of d. The cost is a function of the amount of, how come I use d? I don't know why I use d. Let's do p, or let's do w. Cost is a function of the weight. Cost is a function of the weight. Based on the weight, I can determine the cost. Cost of the weight is $4.75 per pound times the weight, times the number of pounds right there. No starting value kind of thing. This is how much he charges a customer. I want 100 of these, $475. I want 5 of these. We'll take the cost for 5 pounds in weight. That's going to be $4.75 times 5. Substitution. I'm substituting whatever W is there. And C of 5 then, therefore, how much is he going to charge him? It's $20. Give me a second. $23.75. $23.75 for that amount there. So I evaluated it based on the function that I've established. Here's the function. Here's the dependent, independent. Moving on. Number 6, Georgia of Flores charges $10.95 per flower bundle plus a $15 delivery charge per order. So every single order is going to have $15 with it on top of the $10.95 per flower bundle. Great. Okay, so remember there's an additional cost to that rate thing. Let's do the stuff here. Independent per flower bundle. So bundle amount, this is in flowers. Well, this is, hang on. This is number of, I'll just put number of flowers. Number of bundles. You don't always have to kind of have the unit. That is the unit. And the dependent variable is again, the cost. How much he'll charge. That's in dollars. So the cost, let's go back to f of x. F of x equals $10.95 per flower bundle times the number of flower bundles. $10.95 times x. And then plus a $15 delivery charge. Keep in mind, for a single delivery, $15 will be added. Base rate, whether you order 1 flower bundle or 1,000. Always add 15 to it. And this is based on the number of flowers. bundles. If Charlie orders 8 bundles here, we'll do f of 8, and we'll compute that. 1095 times 8 plus 15. Okay, I'm going to do 11 times 8 first. That's $88. Now I'm going to subtract 40 cents because you take away 5 cents per bundle. So that's going to be, well, what did I say? 88 minus 40 is 87.60. Plus 15 is 102.60. So f of 8 is $102.60. That's how much she would charge for that. Like I said, these are pretty fast and all the same after this. Allison owns a music store and sells DVDs at $17.75 per DVD. If Craig orders 5 DVDs, how much does it cost? Looks like cost here is dependent upon the number of DVDs. Independent. Okay? So again, I got to work fast now. I realize how much I talk. F of x, the cost, is a function of the number of DVDs at 17.75 cents per DVD right there. If Craig orders 5 DVDs, we'll take the function of the cost, the function of the number of DVDs. That is 17.75 times 5. Let's do 18 times 5, which is 90. Subtract $1.25 because 5 times 25 right there. So what did I say? 90 minus that is 88.75. I might be doing some math wrong, but that is in my head right now. So f of 5, boom. That is how much it costs. Gotta go fast. Anne buys used cars at an auction for $2,000 per car. There is a $150 fee to take part in the auction. If Anne buys 13 used cars, how much does she pay in total? So again, paying in total depends on how many cars she buys. So number of used cars is the independent variable. How much she pays, the cost there, is the dependent variable. Let's go ahead and talk about cars as C. I'm going to use the variable C and pay as P just because. The payment is based on number of cars. P of C equals $2,000 per car times the number of cars is how much she's going to spend on all the cars there. $2,000 per car times the number of cars. I don't get it though. It's an auction. She probably sets her thing at $2,000. I want $2,000, and she never goes up from there. It's fixed price. Boom. That makes sense. Maybe she doesn't buy some of the cars there because she gets outbid. But okay, $150 fee to take part in the auction. Just for going into the auction area, she has to spend $150 to enter. That probably weeds out some people from just, whatever. So add $150 in this total. Remember, all these are in dollars. How much she paid, how much she paid, how much she paid. All in dollars right there. She bought 13 used cars, so let's do P of 13 right there. That's $2,000 times 13 plus $150 just for entering in there. And that is going to be, 26,000 plus 150, which is 26,000, which is $26,150. Good old Anne. P of 13, excuse me. Wow. My undo sometimes undoes more than I want it to undo. What I'm probably going to do here, because I have 6 minutes left before I got to kind of skedaddle, I'll jump back in and I'll just make the video a 2-parter. You won't know. It's seamless. I was hoping that I could really do it all in one. Looks like I'm not able to. This is in dollars, by the way. Can't really fit it, but let's go and squeeze it in. That's in dollars. Let's do the last 9, I think 9, 10, 11, and 12 for this part. And the last part is going to identify some domain and range stuff on top of what we have. Okay, Harold, a real estate developer, sells houses at $250,000 per house. If he sells 9 houses, how much does he earn? I realize I could have probably just done all the odd problems only, something like that, and I think you would have gotten the gist. You're probably skipping past this part right now anyway. Skip on to, I think, number 13. Let me check beforehand. Let's go to, once you hit number 13, it's going to have a different set of problems where you have domain and range. You're still identifying functions. It's making sense, but there's a little bit more context now that we utilize a domain and say what's possible. Okay, Harold sells houses at $250,000 per house. Okay, per house based on the number of houses, independent. You can identify how much he earns, dependent for that. So how much he earns is a function of the number of houses that he sells. And it's also, of course, based on the cost, $250,000 per house times the number of houses. Boom, you get your value. So f of 9 equals 250,000 times 9. I'm going to start with 25 times 9 and add 4 zeros at the end. 4 quarters is $1, 8 quarters is $2, 9 quarters is $2.25. So I'm going to have $2.25 plus the 4 zeros right there. So that's $2,250,000 for good old Harold. That's how much he earns for selling 9 houses. Not bad. Not bad at all. All right. 3 more. Then I'm out for, you won't know, but then I'm out and I'll come back. Gordon buys 3 HD TVs for $1,200 each. There's a shipping charge of $90 to have the TVs delivered to his house. So assume that he's paying for the TVs all in one single shipment. So that $90 is only being applied once. How much does Gordon pay in total? So with one single transaction, we have the dependent variable, how much he pays. It depends on how many TVs he has here. So f of x, once again, this is your y value, dependent. It depends on how many TVs he buys. $1,200 per TV times the number of TVs. Plus $90 shipping. This is all in a single payment. He's not doing $90 shipping for 3 different TVs. He's smart about it. He knows I have to pay $90 regardless. I might as well do it in one single order. So we'll do f of 3. That's 1,200 times 3 plus 90. That's 3,600 plus 90, which is 3,690. 3,690. That's how much he pays in total for it. And there's your function. 2 more. Sorry. Cindy is buying jackets for her local community charities auction. Each jacket costs $50. If Cindy bought 23 jackets, what is the total cost? Okay, once again, what is the total cost? It depends on the number of jackets. And, first we write it without the 23 jackets, just X. Each jacket costs $50 times the number of jackets. So 23 jackets. Right here. 5 times 23. 23 runs on 115. So 115 with a 0 is 1150. Cindy is raking in the jackets, but losing some money as a result. So there we go. Cindy, your total cost is $1,150. No additional cost to that. One more problem, and I got to bounce and jump right back. Autumn sells laptop computers for $600 each. If she sells 68 computers, how much money does she earn? 68 is the independent. Based on the number of computers, you will figure out how much money she earns as a result. Her earnage is a function of the number of computers that she sells. She sells them at $600 each times the number of computers. So when we evaluate this at 68, we do 600 times 68, which is going to be, well, 6 times 6 is 36, so 3,600 plus 6 times 8 is 48, so 600. 4080. I'm going to say it's that much. $4,080 earned. Okay, so that's it just for a brief moment. I'll be right back. It'll just seamless transition, boom, boom. You won't even know about it. But once I do numbers 13 through 20, it's going to include things with domain and range. Thanks for watching so far. I'll be back very shortly. All right, so I told you I'd be back. Probably a little more disheveled than before. I had to do some online tutoring with a group who I used to live with or live nearby back in the Bay Area, where it was more expensive to live. So put on the headphones a lot. I was doing it for actually a little more than an hour. I am back. I'm going to finish off the rest of these problems. Let's go ahead and now they're going to be talking about domains and ranges with them. So write a function using function notation to describe each situation. This time they don't ask us to identify the independent and dependent variables, so I'm not going to write them out, but I am going to acknowledge what they are so we can write the function properly. Find a reasonable domain and range for each function. So this is the new part that's going to happen on the last 8 problems here. Because of how much remains for what they have. And we'll understand most of these are probably used in a discrete format instead of continuous. If something can or should truly be continuous, maybe I'll act on that. Number 13, Elijah has already sold $40 worth of tickets for a local raffle. He has 5 tickets left to sell at $5 per ticket. Let's ignore the 5 tickets left for a moment because that has to do with the domain portion. Remember, everything here has to do with depending on the number of tickets sold, we don't know anything from 0 to 5, but depending on that x, you get a certain f of x, a certain dollar amount. So we have to use terms with dollars. So the function of how many dollars Elijah has made by selling these is going to be based upon the number of tickets he has remaining, the cost per ticket, the price point he sets per ticket, and then you have to consider the fact that this is all the money he's made. He's already made $40. He's made 40. He's trying to sell some more. This is the function that establishes that. There's a starting point because he already has $40 made. $5 per ticket for the next X number of tickets he's going to sell can get him more money. Okay. So that's that part. That part starts off there. The independent being number of tickets, dependent being number of dollars. Now we got to talk about the domain and range. And domain is in reference to the independent variable, the number of tickets. He can, from here on out, he could not sell any more tickets, or one more ticket, or two more, or three, or four, or up to 5. These are the only values that can exist within the domain. Okay. The range is dependent on the domain based on what he sells. For example, and I'm not going to do this for each one, you probably already know the answer, but if he sells no tickets, we can then determine how much money he'll have remaining by substituting in 0 for x. In this case, 0 plus 40 gives you 40. So the first element in your range, because it does just go higher, the first element in your range is the lowest value, which is $40. After that, he could also sell a single ticket, and at $5 for that ticket, he will now have $45 earned over that time. So the next value is 45. You can tell what's happening here. For every ticket he sells, he gets another $5. So 50 after 2 tickets, 55 after 3 tickets, 60, and then 65. And those are the elements in the range. And it doesn't always map 1-to-1 lowest to highest like this, but in this case it does. Just like that. This is the reasonable domain and range. This is what Elijah understands that he could make based on how many tickets that he sells. And that's number 13. Number 14, Mary has already sold. So same concept. I think I'm just going to kind of write the answer and talk because I do that. Mary's sold $55 worth of tickets right here already. $7 per ticket with 3 tickets left. 3 tickets remaining is the domain portion we'll get into. $7 per ticket times X tickets plus the $55 she has is her function. Her domain, she can sell 0, 1, 2, or 3 tickets. And range is based on domain. Evaluate f of 0, 1, 2, and 3. 0 tickets sold leaves her with $55. 1 ticket sold, 1 more ticket sold is 62. 2 more tickets sold is 69. 3 more tickets sold is 76. So those are the dollar amounts that she can have within her thing. Now again, the domain describes the number of tickets that she has remaining, that she has sold since. The range describes the amount of money that she will have earned based on the number of tickets sold. Number 15, a law firm charges $100 per hour for the first 3 hours plus a $300 origination fee for its services. So everything is based on time in hours, and it says a per hour thing. You know, the thing that makes this one actually discrete instead of continuous is I assume there's probably just this point where they say, okay, let's work at the end of every hour, and then we'll determine the time. If you go 1 minute above, that's in the new hour. Something like that, or say we just end on the hour for each bit. So because they don't want to say you work for a half hour, I'm only going to charge you $50. I think they'd have to tell us that. But there's $300 origination fee as well. So as far as this function goes, the dependent is how much they will charge total based on X number of hours. They charge $100 per hour, and an origination fee, meaning just making this setup, just having this work started, they're going to charge $300 from the get-go. Lawyers, man. Law firms. Way too much. Very expensive. That's your function right there. Everything's in dollars. Everything so far I think has been in dollars, like every word problems. Dollars equals dollars plus dollars. Everything there. Remember, this is dollars per hour times number of hours. Dollars per hour times number of hours leaves you with dollars. That's the unit conversion aspect. Evaluate for the first 3 hours. What is it for the first 3 hours? There's f of 3, f of 2, f of 1, and f of 0 that would have to be evaluated in order to get domain and range. I probably should have done it the other way. F of 0 is 100 times 0 plus 300. F of 1 is 100 times 1 plus 300. You can see we go up by 100 each time. So, domain and range, straightforward. For the first 3 hours, you can do 0 hours, 1 or 2 or 3. And by 0 hours, you have to keep this in mind. It's like you actually appeared there at the law firm. You said, all right, let's get started. Oh, you know what? I got to go pick up Nancy. I got to go. Well, they're going to charge you $300 for going there. Right? That's going to happen regardless. So the smallest amount you're going to pay just by arriving there is $300. After 1 hour, it becomes $400. After 2 is $500. And after 3, it's $600. Okay? That was a little bit different in that we're not saying if you just don't go at all. We're saying that you go, but you just clock out like that. Wasting their time. 5 more problems. A pay-for-service internet company charges $5 per hour for the first 3 hours of service plus a $10 connection fee. Just going in there, connecting, it's $10 to begin with. It's like jumping into a taxi. I don't know if there's a taxi problem, but you hail a taxi cab, and you go in there, and then you get a phone call, and you're like, oh, never mind, my friend's going to pick me up. There's kind of a convenience fee there for like them stopping for you and maybe missing out on another customer. They're probably going to charge you for that straight up just to start, just $4. I don't ride in taxis, so I don't know. Pay-for-service internet company charges $5 per hour, so the amount they charge is dependent on the number of hours. $5 per hour times the number of hours is how much you'll pay. But remember, just to connect, there's a base value of $10. You can go for 10 hours, but that $10 is still applied at the end. Okay. For the first 3 hours, so domain, the first 3 hours is 0, 1, 2, or 3. And again, what probably happens here, you could do what's called a step function here and make it a continuous interval from 0 to 3 like this. Domain could be 0 to 3 because it's not like you can't stop at hour 2.5. But the difference is this probably isn't a constant rate. It's probably not like, again, after a half hour, they're only going to charge $2.50. It's probably the very start of that next hour, they add the other $5 onto it. So you could have this domain kind of thing, but range would get a little tricky to talk about with that domain. So I'm going to stick to discrete functions probably only. The range here, they can charge you $10 for 0 hours, 5 times 1 plus 10, $15 for 1 hour, $20 for 2 hours, $25 for 3 hours. Those are your domains and your ranges for number 16. All right. Number 17. A high definition radio station charges $200. So I mean, I kind of feel bad that like all the problems are like the same. It's, probably should have only done the odds. But the more you know. A high-definition radio station charges $200 per year in addition to $50 per month for the first 3 months to receive its broadcast. Okay? So the $200 per year, you can see this per year, and you might be thinking of this as a rate as well. Let's just look at this within the construct of we're only looking at a single year. Within that single year, what are they going to charge you? And 200 is maybe the start of that year. Just for subscribing to that radio station, that HD radio station. So function of, again, cost is based on time, dependent on time. $50 per month. Time is a number of months here. So $50 per month times the number of months is how much you're going to pay total after those number of months. Just for doing it for the year alone, you'll have a base value there of $200. So here's the function for this one. Over the course of that year. Within the first 3 months, once again, domain, 0, 1, 2, or 3 months in, you're going to be charged a certain amount. I hope that there's one where something declines over time. We haven't seen those yet, but I would have liked to see something go downward. So you can see that the range goes in increasing order with domain, even if they don't map 1 to 1. But 0 months in, you're only going to pay $200. After a month, $250. After 2 months, $300. And after 3 months, $350. Okay, got 3 more problems. A newspaper charges $3 per line for the first 4 lines, plus a $20 fee to advertise. So I guess this is you wanting to get in the in the advertising part of newspaper, which I haven't done before. I don't know if this is realistic or not. You guys are like, what's a newspaper? Everything's online now. You can probably charge online somehow too. $3 per line for the first 4 lines. Who knows what they do after that? Maybe 4 lines is the most they can have you do. Who knows? $20 fee to advertise straight up. You reserve a space, they're going to charge you $20, and now they ask how many lines. You say 0. Well, it's kind of up to you. I don't know if that's going to be reasonable in this case or not. I think 0 generally can be reasonable. You know what? For this one, why don't we go ahead and pretend like 0 doesn't exist in this one? I don't know if that'd be true or not. I like to include 0. But let's say that in order to even be considered, you have to at least have a line of advertising space. So let's do this one a little bit differently. So f of x, excuse me again, my fault. F of x here, the amount of dollars that they're going to charge you is dependent on the cost per line times the number of lines that you are using, up to 4, plus a $20 fee just to start up. Okay. Let's say for this domain this time though, let's say this time you can't, you can't go without actually adding a line in there. Let's just do 1, 2, and 3 this time. By the way, half a line is still considered a line. Once you hit that next line, it counts. So let's try 1, 2, and 3 this time, because I don't think you'd be able to reserve part of an ad space and not give them any lines. Maybe you could, but that's okay. So let's do it differently this time. Let's talk about $23, $26, and $29. Again, assuming that you're plugging in 1, 2, and 3 in for x to get f of 1, f of 2, f of 3 right here. I'm sure the answer in the back or whatever you'd say probably includes 0 and 20. I don't know. But they said reasonable domain. I'm going to be a little bit within reason differently on this problem here. Number 19, Matt has already sold $72 worth of tickets to the benefit concert. He has 6 tickets left to sell at $9 per ticket. So I think you're making sense of these enough that it's all working out. This is all dollars, and this time it's number of tickets. It's not time. It's not time anymore. So we have, we're going to sell $9 per ticket. Multiply that by the number of tickets that you sell. That's how much money you're going to make with that. He's already sold $72 worth. So that in itself is going to be going up from 72. Now he can conceivably not, oh my goodness. He can conceivably not sell any tickets. You have to understand that that's one of the things that can happen. Any more tickets since here. So 0 tickets sold, or 1 or 2 or 3, 4, 5, and 6. This one could not possibly be a continuous function. It must be discrete. You can't sell half a ticket or anything like that. Get half the cost. So $72 for selling no tickets, plus 9, plus 9, plus 9 each time. That's how multiplication works. 81, 90, 99, 108, 117, and 126. So those are the amounts that you can, let me count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, so those are different dollar amounts that he can make from here on out for the benefit concert. Go Matt. Last problem. Sarah has sold $33 worth of tickets to the comedy show. She has 4 tickets left to sell at $11 per ticket. Same deal. So unfortunately, all these problems only go up. I wish some did go down, and we could talk about reasonable domains as far as like how much more you're able to spend. Like they wouldn't even talk about it that way. But $11 per ticket times the number of tickets that you do, up to 4. Plus $33 already earned for that. There's our function. Independent variable is number of tickets sold. Dependent variable is number of dollars she's made. Domain, again, she can sell 0 tickets, 1, 2, or 3. Yeah, next time I'm going to look for, or 4. Next time I'm going to look through the problems a little bit more deeply and decide. I think the odd problems or even problems alone would have been enough for this one. My bad. Maybe I could have done it within the half hour then as well. In the range, you can have 33 for not selling any, or 44 for 1, 55 for 2, 66 for 3, and 77 for 4. Okay, so that's it. I'm going to cut this thing short right now. I'm generally hitting 45-minute marks for these practice problems anyway. I think you're understanding why. But no, thanks for watching. Hopefully this covered this thing in great depth. I wish that it did some where they declined, so we could talk about how the range clips the domain. Didn't happen. That's okay. I hope this stuff is making sense as far as independent, dependent, domain and range, some unit conversions, and identifying things with functions all within. Okay, that's it. Take care.